Hi guys, my name is Peter, and in this video, we'll be building a simple fast API service, and we wouldn't just be settling at that. We would also be adapting the WebSocket service so that it would function in a production-like environment where you would have different workers in your VM or have different different app instances of the particular application. um yes, so let's just get right to the video. Yeah, so currently the main focus of this video will actually be building it so that it can function well in a production like environment where you have different web workers. And yeah, we'll be using Redis for that. We'll be using Redis to make sure that everything works as it should work. Right. All right. So we'll be using Redis Pops Up. We'll be using Redis Pops Up, and if you want to like check more about what Redis Pops Up is, you can just basically come to this article. I think it is really explanatory as to what Pops Up is and how Pops Up works. And yes, like I said, we'll be building with Fast API, and there's an interesting article actually. This particular article that explained the whole WebSocket thing and even goes into further details as regards building one that is really that's really nice actually. So because in this video we'll be building a very simple WebSocket service, just very simple bare bone WebSocket service that's really kind of explains how to achieve the particular fit. And as usual, you can surely build on it and adapt it to your specific needs. So I have also built a chat application, and this is like a full blown chat application. It's just the way you would want to handle the several workers with fast API, with the WebSocket service fast API. I've actually like built one. You have the user ID, the room ID, the message you want to send, and the particular room ID you want to send. Each this contains more details and follows better guides as regards achieving this particular fit. You can basically I actually built two variation of it. I built one with the number in memory um in-memory connections list, and I built one using Redis. Like I assume in this video that you are cool with fast API. You don't need to be super cool, and also that at least you have gone through the WebSocket area of this particular the WebSocket portion of the documentation. I feel the documentation is really nice. That's something I really like about fast API. The documentations are just awesome, and you can basically go through it because I wouldn't be going through some things that has been explained here. I'll just be going right that okay us we building it so that it would the WebSocket service will actually function be able to function well in a production like environment where we have two or three web workers and different instances of the fast API application. Right, so let's just dive into code. Yeah, so yeah, I have a simple fast API application that's basically it's just a simple WebSocket service really. A user can connect to a particular channel. He or she supplies the channel ID, and after supplying the channel ID, the WebSocket is accepted and the user is added to a channel. We'll get to that in a minute. I will explain the whole thing about the connection manager. And yeah, as usual, as it is explained here, while through we accept the channel, we wait to receive a text and we send the text. So that's basically what we are doing here. We wait to receive a message and like send a message to the particular channel that the user connects to. Yeah. Right, so in your case, you should actually handle WebSocket disconnect. Maybe this like since we'll be using the list to hold the WebSocket connections, you can basically pop the user's WebSocket instance of the list, and you can. That is not the focus of this video. You get, so I wouldn't be going into that. So let's just dive down into the brain of this whole thing. That's the connection manager. And so the connection manager, this one do message broadcast to all connections to this particular service. So self connection will be an in-memory DB. Like I said, we'll start from the in-memory DB that wouldn't work in a production like environment, and we'll go through, and then we'll walk through and just punch our keys till we achieve one that actually can function in the in the in the production like environment, right? So we have the list of connections will basically be, if you have gone through this particular thing, you would have seen the connection manager here. Yeah, so this is it. The is basically is in a list of connections, but this, in our case, since we have channels, we'll be having channels that users can connect to. So different users can connect to different channels. We are basically having a dictionary, that the key of the dictionary will be the channel ID, and the set will be the WebSocket instances, will contain the WebSocket instances, and as you can see, we kind of have defined it here, right? So let's just go through the add user to channel method. The add user to channel method basically adds user to a channel, to a particular channel. So just keep a mental image of this particular channel, of this particular connections data structure. Right, so okay, we have the, if the channel ID is not in connection.keys, that means no user has actually subscribed to that particular channel before. What we should then do in that case is we should basically create the connection ID, create the channel ID in that particular, in this particular connections list dictionary, and add the user's WebSocket connection. Or if channel ID is actually in this, is a key in this particular dictionary, that means someone has actually connected to this particular channel before. So what we can just do is basically add the user's WebSocket connections to the particular connections list, and we'll need the connections, the connection, the WebSocket connection instances to send messages to the particular user. So we just return true, connection successful, blah blah blah. So all right, so send message to channel. Basically we just check, okay, if the channel does not exist in the connection or keys in your own production, in your own application, you might want to like maybe raise an exception or just do anything really, because that means an error has actually occurred. A user shouldn't be able to join a channel that does not exist, talk less of sending a message to a channel that does not exist. So that will be some bug for you to crush. All right, so basically we get the whole connections in the particular channel, for that particular channel ID, and we send the message to the whole connections. You get, so there's this utility function I've written here, send message to WS connections. It basically take a WS connection, a WebSocket connection instance, and sends a message to that particular instance. You get, so yeah, so that's just that about the whole thing. So let's just put this application to test. Right, so let's just do uvcon main app. Okay, let me make sure this thing is still recording, please. Okay, it's still recording. Main app, let's have, yep, let's just run this. All right, we are currently running the application is currently running now. So let's basically come to our postman, and I currently have two WebSocket requests here, and I will be connecting here. Okay, I've connected here, and I'll be connecting here. Right, so I've connected in two different places. So let me just try to send a message. If everything goes as planned, if I send a message here, I should actually receive the message in the WebSocket connection too. And the reason why I'm actually putting it like this is because from our code here, you can see that we are kind of expecting a message, data message, you get. So we are kind of expecting a JSON. So hello there. Yep. So let's send this hello there, channel 1, hello there. If everything goes right, we should actually receive the message here. Oh, yeah. Everything is functioning as it should. We receive the message here, and if we send the message from here also, a message hi there, we should receive the message there also. Yep, idea. Right. So now that we have been able to ascertain that okay, this particular application works. So, okay, let me now try to like mimic what might actually want to what might actually be the case in a production like environment. So basically, since we have two different FastAPI instances running, and as you can see here in this particular application, we are currently using an in-memory database. So should I call it okay, in-memory list? This is the particular dictionary. This is like the dictionary that holds all our sockets connections. And let's kind of mimic that particular behavior. Let's run a separate application in a different port. So basically let's disconnect from this. Let's disconnect all this. Let's disconnect. Let's disconnect. And let's just Control C. I'm just copy this. Ports. Let's run this one on port 8000 and have another application running. Icon main app. Let's run this on port 8001. All right, we have two different applications now. One is running on port 8001 and another is running on port 8000. So now let the first WebSocket connect to port 8000. Let's just clear all these messages and connect. All right, we have connected to this application. Let's now connect to the separate application that is running on port 8001. So let's just connect to this application. All right, we have connected now. And as you can see from the console here, we connected successfully. As you can see from the console here, we've connected successfully here. So right, so now let's basically let's try to send a message. Yeah, let's see if this other user will be able to get the message. Let's just send idea. Oops, we didn't receive the message. What could be wrong? So let's try to send the message here again. Idea again. This guy should. Oops, we didn't receive the message. What could be wrong? And let me just try to explain what is happening. The reason this is actually happening is because we currently have two different FastAPI applications, and each of them have as a list of WebSocket connections they are connected to. So basically, in this case, let's just imagine that okay, let's just try to picture us having two different applications, right? So for this particular application, it should only contain a channel ID of 1. So basically, let me just try to just do this to have a channel ID of 1, and it should contain only a single WebSocket connection, same as the other application. So since we have two different applications running right now, each of them will contain only this only one a channel 1, and each of them will contain only a WebSocket connection. So that's the reason why whenever we send a message to one, since the other service does not know about this particular service, then it wouldn't be able to send message to that particular WebSocket connection, and that is what we'll try to solve right now. If we go back to the documentation, you would see something. This app, the app above is a minimal. Oh, sorry, forgive my English. The app above is a minimal and simple example to demonstrate how to handle and broadcast in messages to several WebSocket connections. But have in mind that as everything is handled in memory in a single list, it will only work while the process is running, and will only work with a single process. If you need something to integrate with FastAPI that is more robust, supported by Redis, PostgreSQL, or others, check Broadcaster. Yep. and this is what we would be using. We'll be using this particular amazing package created by Encode. Encode are the developers of Starlit and also of Django REST framework. So Starlit and Django REST framework and some other very cool libraries we have in the Python ecosystem. All right, so let me try to give us a brief of what Redis Pub Sub is. So just for us to understand what Redis Pub Sub is really, let's kind of think of a okay. We have several people and we have several TV stations, right? And someone we have the publishers and we have the subscribers. Someone who gives us information is actually called the publisher, and that's, let's just assume they are our TV channels right now, and the subscribers are people who listen to a particular channel. Okay, I watch this particular TV station, right? So that's basically what broadcaster help us do. It helps us to listen to a particular channel, and whenever a separate process that we don't care about, who is a publisher, kind of sends a message to that particular channel, we would be able to broadcaster would basically get the information that was sent. It Since broadcaster is listening to the particular channel, it would get the message that was sent to that particular channel and sends it to us. You get? So send it to us who are the subscribers. You get? So it's basically like, okay, broadcaster is like the old telecommunication the old telecommunication technology really. It functions to get the information from the producers who are the broadcasters to we and that are listening to the particular TV station. So that's just a simple definition, a simple introduction to what Redis Pub Sub is and what broadcaster is, right? And now, as you must have guessed, for our application to actually work across several servers, we basically have to listen, or we actually have to make use of of same same Redis database, and I will be taking us through all that. To be basically writing code and doing all those. Yeah. So right now, let's just get to it. So let's just quit all this. Let's quit these two instances we are running, and let me just clear this and clear this. I don't know, just it clutters my head, right? So after clearing them, now let's just we'll be working on revamping this so this actually kind of support it. First and foremost, let us import let's install broadcaster. So let's just copy this broadcaster Redis, since we'll be using Redis. Just pip install this. Oh, sorry. Let's pip install broadcaster. All right, Redis and broadcaster has been installed. Now the basic KPIs that broadcaster actually like provides for us are the publish, the connect, the disconnect, and the subscribe. So let me see if I can get it from here. Broadcaster, let me see. Let's see the base. I think this base contains everything we need. All right, as you can see, it basically provides the connect, the disconnect, the publish, and the subscribe, right? So those are just the public KPIs that broadcaster exposed to us, and those four are actually what we'll be using for now, right? So now let's just go into our PyCharm, and since we have broadcaster running now, let's us just have, so the steps we'll be taking now to do, let me just kind of highlight them. Things we need: add a function to connect to Redis and to Redis here. So next via broadcaster, and okay, add a function to connect to broadcaster. I'm sorry, to subscribe a channel with broadcaster. add a function. Oh god, I forgot how to spell function there. To publish to a channel with broadcaster. Add a function to connect from Redis via broadcaster. Alright, let's just correct that. Yeah. So from here, let's just basically add a function def connect. Let's just have this. Basically, we'll be doing self dot broadcaster. Okay, now let's just do this. Okay, do you know what? First, let us basically spin up our our Redis database. So basically you'll be using Docker. I have Docker installed right here. You can basically install Docker if you don't. Docker run. Let's have Redis. Oh, sorry. Let's name the Docker. Let's name Docker instance. Name equals to. Oh, sorry. Name Redis FastApi. Let us run it on port. Let's run it on port 63378, and let us map it to 6379. Since Docker will basically be running on 6379 in the container so it's let's just map our normal local 6378 to 6379. And I don't want to run it on 6379 because I have a local Redis instance running on 6379. I don't want us to tamper with that actually. So let's just have that, and Redis, this is the container the image name. So let us run that. If all goes fine, we should have a Docker container. Yep, we have a Docker container running. Let's see, let's check it out. Yep, we have a Docker container running. Right, so let's basically come here. Let us self.caster equals to broad. Okay, let's install from broadcaster, import broadcast. Yep, so let's just go through what they have here. So broadcast, let's just copy this. So broadcaster equals to Redis localhost. Our localhost is currently running on 637.9 637.8. Let's just have it like that. So self dot to connect, you just do self dot broadcast dot connect, and to disconnect, disconnect. Let's do self dot broadcaster dot disconnect. All right, so we have currently done this. Disconnect from Redis, connect to Redis. Okay, we're actually not fully done. Let us basically connect to Redis before the application starts. You get, so once we have initialized this, before the application fully starts, let us connect to Redis. Right, so to do that, we'll be using the utility functions that FastApi has actually provided for us. That is on startup and on shutdown. Let us just research about that. FastApi on startup. Yep. So let's check out on startup. Okay, yep, I think that's it. All right, so we currently have this. Let us basically copy this on event startup. Yeah, let's just have our connection manager dot connect, and I think let's just check the shutdown. Shutdown. Pew, pew. There should be shut down. Alright, it's almost same thing. So let's just do this. Sync def shut down. So shutdown event. Let's connect. Okay, so let's just come here. That is wait. Alright, so we currently have the shutdown, and currently have these two requirements checked off, and we have this requirement checked off also. Now let's work on subscribing to a particular channel with Redis, right? So the point where we actually want to subscribe to a particular channel is whenever we encounter the channel once, because and the best place to kind of get to whenever we need to kind of connect to a channel to subscribe to a particular channel on demand is whenever a user tries to connect to the particular channel. So basically we can just say, okay, we can't we actually can't connect to the old channels in the old world, right? Yeah, okay, we have infinite number of combinations of letters, of characters, of numbers. So basically all we'll be doing is that we'll be connecting to every channel, we'll be subscribing to every channel on demand, right? So let's just do that. Let's just work on connecting to every channel on demand, right? So this place will actually be connecting to every channel whenever a user is added to the channel. What we'll just basically do is that, okay, whenever a user is connected to a channel, let us check if the channel has been subscribed to before. If the channel has not been subscribed to before, let us subscribe to the particular channel. And if it has not been subscribed to before, let us subscribe to the particular channel. So let's just write a function to subscribe to a particular channel. Let's make it private, since we don't care about it outside yet. Subscribe to channel. So channel ID string. This will be as async def. This will be an asynchronous function. Just basically do this, and let's just come to our browser, grab these. Yep, this is grab this and put this guy here. So self that's broadcast the subscribe channel, basically be channel ID, and Websocket. So let us just pass this for now. Let's just pass for now, and let's just print event. Let's just print the event, right? Now let us work on connect subscribers to the channel, right? So let's just do this. So the instance whereby we subscribe to the channel is going to be when we know that we have not encountered that particular channel before, and the only place that we kind of have that check in place is here. Once the user gets here, we are very sure that, okay, this channel has not been encountered before, and since we are subscribing to the channel on demand, let's just subscribe to the particular channel here. Wait, subscribe. So let's subscribe to channel ID will be channel ID. Yep. And now let us now work on sending a message to the particular channel, right? And to send a message, like I explained, okay, let me just try to list the APIs that are provided by Broadcaster. We kind of APIs by Broadcast. We have one, we have disconnect, we have connect, we have subscribe, we have publish. Yep. So we have this, we have correct. I've actually used this, we have used this, we have used this. Now let's just work on using this publish. So as usual, let's just come back here, check through. Okay, so here is where we have the function to publish to a particular channel. So let's just come here, and whenever a user sends a message to a channel, this is the message. Let us wouldn't be the one like doing all this. Let's just basically publish to the particular channel. Yep. Let's dev send a message. Send message. Let's just put it as send message. We'll be doing something later. Channel ID string message string pass. Okay, so send message to a channel. So let's just send message. Basically what we'll be doing, let's just paste this. Should be an async def await broadcast self the broadcast the publish. Channel is going to be channel ID and message. Yeah, so this is just basically what we need. This is just basically what we need to send a message to a particular channel, right? So I for now will actually not need this. We'll actually not need it, but I'll get back to that. So right now let us check out things how things actually works, if everything works right now. Let's just come here. Instead of this particular send message to channel, let's just have this here, send message. I'll actually rename this send message to channel to send message later. I would kind of shows the reason why I just want us to move progressively, like build on what we have actually built before, because I feel that's actually a better way to learn stuff than just giving us everything. It's basically very much better to kind of do something, see the repercussions, and this is what will happen if we don't do it like this. That's a very, very great way to learn, because you basically don't only learn how to do it, you learn about the faults, and you can even come up with your own solution to that particular fault. So let's have that. Await connection manager. Let's connect. Await connect. What is happening? Coroutine was never awaited. Oh, yep. Await. So this should be an async def. Async. This should be await, and this should be await. Yep. So let us try that again. Yep, seems like we have everything connected right now, and we'll try to send a message to a particular channel. And as you can see here, subscribe to channel, I'm basically printing the event. So let's just come here and connect to the channel. We still have our Redis database, we still have our Redis instance running. So let's just come to our postman. Let's clear all these messages, and let us connect to channel 1. All right, we have successfully connected to channel 1, and let's connect to the same instance. Let's connect to the same instance. 8000. We have connected to channel 1. Let's send a message now. Message ID. Message. I don't expect the message to be sent actually. So as you can see, the event is actually being printed here. We can see the event here. So if I send another message now, you'll be able to see it. Right, if I send another message, let me just send an ID again. Let me send this. You'll see. Sorry, why is the message not sending? Let me connect this. Send right there. This is doing. Oh yes. Now here comes one problem. Let me explain the problem to us. Right now, the problem we are currently have right now is that this particular instance, this particular guy here can't send messages, but this particular guy here can send messages. And the reason is that let's come to our main.py, so I'll explain it. So on entering the particular thing, okay, the WebSocket does accept, that means the person will see connection accepted there. We are okay, connection manager dot add user to channel. Let's just take a look at this. Once you check this out, you would see that okay, the channel does not exist. Okay, await subscribe to channel. This basically continues to listen. This particular coroutine is that actually does not end, because broadcast basically continues to listen. So it is a forever process, and we need to subscribe to the particular channel, but we need to be able to go down to the part of the code where we can send message, because right now the first person that tried to connect is still stuck here, is still stuck in this portion of the code. This particular portion of the code has not been run. You get? So now that's actually one problem. You get? So okay, let me just try to elaborate. Let me try to explain the reason why the other user is not stuck in this. The reason why the other user is not stuck in this is because when we try to add the other user to the channel, since both of them actually connect to the same channel, which is one, we'll see here that this particular if clause here wouldn't be true, because the channel has been connected before, has been seen before, therefore it will exist in this connections list. But this, so basically it just comes to the else clause and adds the user to the user WebSocket connection to the particular channel ID. So that's the reason why this other user here can't send a message, because the first user that tried to connect to the particular channel is still stuck here. Basically, we are still stuck at the portion whereby broadcast is still listening to the particular connection. And now, what can we do to break out of that particular thing and have broadcast listening in the background? A way we can do that is to basically use the Asyncio library that is provided by Python, right? So let me just go there and I'll basically try to explain how everything should go, right? So what we're trying to do here is that we'll be using the asyncio dot wait function. Let's just check out the asyncio dot wait function. So asyncio dot wait. Just check through the documentation. Yeah, so you can basically just read through the documentation. It's quite explanatory. And the part where I want us to discuss about is the part where we would be creating. Okay, let's just check through. All right, yeah, this particular part where it comes to creating tags, you get. So asyncio dot wait basically, as the API is just okay, you can wait for two different coroutines to run, and you can basically tell asyncio that I want to break off from this particular coroutine if and only if one has been completed or both has been completed or an error occurs. You can kind of give asyncio the clause or the events that should happen that would allow us to quit from that particular process, from that particular coroutine process right now. So we can basically feign that particular process. So let's just create a subscribe tags. We'll be using the asyncio.create tags. So let's just come to creating tags. Asyncio.create tags. Let's just create the tags. Let's first import the asyncio library. Import asyncio. Just delete all this also. So basically we're doing asyncio asyncio.create tags. You get. So the first one will be, let's just have this here, this particular coroutine here, asyncio.create tags. And also one thing we cannot do is that we can now kind of sleep for a second, and since we know that if we sleep for a second, the particular sleep process would end after a second. So we can kind of tell Asensio that, okay, run this particular two tasks in parallel, and once one completes finish, let us like basically get cut off, or let the particular curating process finish. So basically you're running two different curating process in parallel, and you can basically stop waiting for the curating processes if one has completed. So that's, we can actually use Asensio to achieve that. So let's just do wait task equals to Asensio. I will show Asensio dot create task, and we'll basically be sleeping. You can't use the normal time dot sleep here. You actually have to use Asensio dot sleep. Let's sleep for just a second, right? And now let's just do await Asensio dot, why do I keep Asensio dot wait. Now let's just subscribe tags. Okay, sorry, subscribe tags, wait tags. And now let's just look at the API, the documentation for it. So you can see Asensio.wait. Basically, we have different functions, and now you can see what I try to explain. So you can see that we have return when. So basically, that's when, okay, just basically stop this particular coroutine. You get, stop this particular coroutine whenever one has completed. So but this particular one is all completed. That means we actually have to wait till all are actually completed, but that's not what we want. We basically want to cut off the whole thing whenever the first one has completed, and that's going to be our wait task, our associated sleep, since we know that one will basically disconnect after 2 seconds, or after a second rather. So we'll basically be doing return when, you get. So right now let's just check this through this stuff. The documentation and the whole thing is actually like, it is your friend actually. So let's just do return when first completed. So basically here we'll be returning when the first thing has completed. You get the first task, and we're very sure that for the first person, this particular subscribe task will want to continue forever. So we'll basically like, this wait task will complete before this particular subscribe task will complete, because this subscribe task basically runs forever since broadcast continue to subscribe to the particular channel, right? So we are very sure that these wait tasks will basically like would complete first. So this whole process will like kind of be completed for the first person that connects to the particular channel. So once we have this, let us try the whole thing again. Let's just try the whole thing again. Let's just try to connect this particular user to the channel again. Let's see if everything will work. So let's disconnect these users. Let me clear all messages. Connection successful. Connection successful. Now let's just basically send a message from this user ID, which you see the event being printed here. The event, this other user too, once you send the message, you should see the event ID again. So the two users have successfully connected. Okay, do you know what? Let's just do a little bit of experiment. So let's just do all completed. And let's just do all completed. Oh, we don't have reload here. Let's just Control C. Okay, sorry. Let's just have a request run the particular application. Now let's connect both users again. You will see that one particular user, this LOD again, wouldn't be able to send a message. So let's just connect this particular user also. Both users have actually connected to the particular channel. Now let's try to send a message from this user ID. This gets sent. Let's send from this particular user ID. As you can see, the first user that connected, his message isn't sent because this particular line here, we are still waiting for all processes to be completed, and we know that this particular subscribe process here would always continue to run. The coroutine will actually not stop running. it will not stop running in a particular background, or it will not return anything. It will just continue to listen to the particular channel. Now, let us just return back to the first completed, right? Let's return back to the first completed, and let us control C this. Okay, I have no idea why that's happening. I'll check that. That's not the focus of this particular thing. Let us have reload, because I don't like the whole thing. All right, so let's just have reload. So once we control S, everything works. All right, so let us come here. Let us connect to the channels again. And if we send a message, we should see ID here. If we send this message ID again, we should see ID again. Yep, so everything works. Now let's now work on sending the messages to the old WebSocket connections. And how can we do that? Just here, instead of putting the events, let's just basically just send self.send message send message to channel. We have a function here, send message to channel. Let's just make this in private. Yep, let's just send message. Let's have this send message. So let's have send message to channels here. So this one will send message to the channel dot send message to channel ID equals to channel ID and message equals to event dot message. As we can see here, the event has a channel, it has a message instance, right? So let's just have event dot message. This is a coroutine, so let's just await it. And yep, right now we should be able to receive messages in all our WebSocket connections, and as you must have guessed, everything will work as very fine now. So let's just basically connect to our WebSocket to connect our client again. Let's clear our messages. So connect, yep, connected successfully. Clear messages, connected successfully. Now let's just send a message. We should receive the message in both WebSocket connections right now. So let's just send a message. Okay, something might be happening in that case. Connection manager has no attribute send message. Oh, we forgot to change it. Sorry. Send message to channel. Let's have this send message to channel here. Yep, everything should work fine now. Let me just clear this message, because I don't like the messages. I don't like the previous message. I'm doing a new connection. So connect right now. So we have these two instances. The two instances have connected. So let's just let's send a message. Yep, we received the message here. If all things go well, we should receive the message in the second user also. The moment of truth. All right, yep, we received the message in the other user right now. So we have received the user in the message in the other user. Now let's now try what we did for the previous implementation we had. We just run the application in two different ports to mimic having two different workers or having two different instances of FastApi opened. Let's just Control C. Let us clear this. Let's just work. Okay, let's just run this. Yep, and let us also run this in the separate ports. Okay, let's do Ubicon main app reload. Port 8001 reload. All right, we have another application running on port 8001 right now. So let us come here. Let's disconnect from this. Okay, we have actually disconnected. Right, so for this particular first guy, let us connect to port 8001 to the other instance. Okay, we have connected to port 8001. Let's connect to port 8000 here. Connect to port 8000. So basically, both applications are connected to different ports, but to different applications in this case, but they have connected to the same channel. So let's try to send a message here. If everything goes fine, since this particular other user, this particular web server connection should receive the message. So let's just send this channel 1 hello there again. yep, we receive the message in the other channel. And that's basically happening because the broadcaster is actually listening to the same channel on the same Redis database. So if we send a message to a channel, each instance will actually receive the event since they are connected to the same Redis database. And yeah, that is actually like we have achieved the goal of this particular video. We have connected to different Redis database, to different we have kind of simulated how things would look like in a production service, and that whereby you have two or three or four or more workers of fast API application instances behind maybe a load balancer or something. And yeah, I hope I hope I've been able to explain it succinctly. And yes, you can basically expand on this. I have built, like I said at the beginning of this video, I built a full-blown chat application where every user has an ID, has a room ID. You can send a message to a particular room ID just the way WhatsApp does it. You can send a message to a particular chats, to a particular group chats, to a particular user. So all these are actually kind of demo there, so you can kind of look through this. I think I would do well to add this to the description, and also this broadcast website, this channel, this particular um this particular article is a nice one to read. You can basically go through the article and check through every single thing. This everything you need is actually here. You can just check through and see how tokens are even managed. He actually even went forward and actually showed how you can try to manage security with the WebSocket, right? And yeah, just check it out. And as all YouTube guys will do, um you can do well to subscribe to my channel, click on the like button. I don't know how to do that stuff. Okay, subscribe to my channel and click on the like button. And yeah, see you around.